All right, so we're gonna get started with morning lecture in a second here. I'm gonna do my best, like we're gonna be coding on this screen. There's a lot of us in this space. Those of you who are in like the far back, if you're like need glasses or this might be a little far for that, again, I'll do my best, but I'll show you an example. So this might be some code we're looking at. I can bring it up to this size. If I zoom in more than this, it becomes really hard to see the code itself. So if this is too small at the back there, then just come up close. You don't need a desk necessarily. You can bring your chair over here as well. But yeah, and if I do bring something up and it's too small, just like throw a hand up and be like, yo, zoom in on that, because I can, if we're looking at other content. Okay, so I'm just gonna check in with Victoria because they are with us for the stream. Can you hear me well, guys? And I'm also going to ask if any of you guys have your computer up and you have Slack open, if you can just join the Web Full-Time Victoria 16th September Slack channel and just keeping an eye on it for me. I'm going to do my best to be looking at the Slack channel as I lecture, but you guys in Victoria, if you have any questions or if anything with my stream is not going great on your end, just let me know in the Slack and I'll do my best to make sure I'm not forgetting you guys. But for those of us in Vancouver, if you guys can keep an eye on that as well, it'd be super helpful for me, just so I don't forget or miss any of their questions. It's this one here. So web-ft-vic-16 should come up for you. And then you can also, chat with those guys over in Victoria because they'll be going through the same thing that you guys are going through here. So welcome to boot camp. 1 day down. I don't know how many to go. A lot. But it's exciting. I'm glad you guys are here. I think you guys are going to have a lot of fun. It's going to be a lot of hard work, but you're going to learn so much. And yeah, I'm excited to work with you and get to know you a bit better. So I know you guys had a bit of an intro lecture today, but this marks our first kind of technical lecture. These will be the norm for now on every morning. We're going to be starting at this time, usually going for about 2 hours, looking at some topics of interest that you've been learning, technical things. There'll be a lot of times some live coding, and we'll look at what that means throughout this lecture. I guess first off, a little bit about me. I studied at SFU in computer science with actually Nima, who's the other instructor. He's not there right now. I don't know why I pointed. I specialized a bit in computer graphics. I think of myself as a bit of a hobbyist game developer. So if that's something you guys are interested in, we can talk about it. Of course, I'm a web developer. That's why I'm here at Lighthouse Labs. And I really like rock climbing. So if that's an interest you have, we can go boulder or climb sometimes. And today we're going to start with a bit of an overview of the curriculum. We're going to go into what writing code incrementally means. We're going to look at Git and explore that to some degree. And we're going to look at some problem solving tips and debugging. But overall, the theme of today's lecture is like the dev workflow. So as programmers, as web developers, what are some tips and tricks to make our programming and our day-to-day activities a bit easier and run a bit smoother? Before we get into any of that, though, let's just check out what you guys signed up for. Here we go. So, a web immersive bootcamp. Just as a preface, these slides, we're going to go week by week what you guys are hitting throughout the bootcamp. There's going to be a lot of technical stuff in there, and we don't have to, as a group, understand very much of it. It's just there for interest to see, like, oh, I've heard of maybe Ruby on Rails. That is something we might cover later on in the course. The depth it goes into is probably going to, be a little bit too much right now because we're in the first week. We're still understanding some of the fundamentals, but it's there in case we're interested. To start off, every Friday of a general week is going to end in a fundamental, or every week is going to end in a fundamental Friday. And this is kind of a departure from the standard content that you'll be going through from Monday to Thursday. Usually there'll be a programming test on the Friday, but also the Fridays will focus on more computer sciencey topics. And later down the line, you'll have some chance to do some research and write and reflect activities. This is your chance to kind of revisit just fundamental programming, some more logic and flow concepts that you might not be hitting in just a normal web development kind of context. The first week, we're focusing on software fundamentals. You might have seen this acronym thrown around, FOCAL, and that's standing for functions, objects, conditionals, arrays, and loops. And we're going to be looking at, like this day's lecture, the dev approach throughout this week. So that's like, what are the things that help us with code style, quality, testing, debugging, problem solving, making us more efficient, just that doing the soft tasks around actually programming. Week 2, you're going to get more into something called asynchronous control flow, and you're going to start to look at networking, HTTP, and APIs. So networking is the internet. It's the thing that actually makes this a web development bootcamp. And then, like I said, it's going to end with that fundamental Fridays. You'll have your first programming test this Friday. It's going to be a mock test just to get used to the setup and what it's going to feel like. So don't worry too much. And then next week, you'll have your first kind of real programming test. The theme throughout these programming tests is most of them will be kind of focused on this like focal style of questions that they'll get a little bit different as you go on, but it'll remain kind of close to what you're seeing in these first 2 weeks. Weeks 3 to 5 are web application fundamentals. This is when you're going to finally start to build an actual web application with a front end and a back end, having both parts communicating with each other. We'll see a bit more when we get to that point what that means. You'll be working a lot more with HTTP requests and responses. Week 3, you'll be looking at kind of servers, which is a back end thing. Week 4, you'll be doing the front end. Front end is the idea of like what visual user interface is shown to the user and how do they interact with it, whereas the back end is more concerned with the data and the computations we need to do around deciding what we give to the user. Finally, week 5, which is what these guys are on right now, the ones in that room, you'll be starting to learn about relational databases, databases being the places that we store large groups of information in organized ways. And then, Fundamental Friday, continued throughout the weeks. Week 6, this is an exciting week. You get to do a midterm project. This is your first chance to kind of flex what you've learned. With the midterm project, we define the teams, so who you're working with. The stack just means the technology that you'll be using to build these applications, and the requirements. So this is very similar to like a real world project that you might be set on once you graduate bootcamp and get a job. They'll say like, oh, we need you to build X with Y, and you have this team to do it in this time. So very similar. The midterm will follow that pattern. You'll start to see some project management, life cycle, and collaboration, which you might not have kind of dealt too much with up until this midterm project. Before here, there is some collaborative work, but it's mostly kind of you working through the activities on your own. Midterm project is kind of a nice time to start to work together and collaborate. And at the end of it, you'll get a chance to demo to your peers and other people taking the program. 7 to 10 is kind of where you bring in the big guns. So you've built up all this fundamental understanding of how web applications work, and you start to get introduced to web frameworks. Web frameworks are these big structures and opinions on how we should make a web application. They can make things more organized, easier to do, faster to develop, and we're going to start seeing some of them through these weeks. Ones you'll be looking at are like React, Ruby on Rails. Those are the two main ones. And throughout all of these weeks, usually you'll be learning these overarching concepts with a project that you have to complete. So this week you have low tide. In the next weeks, you'll have other projects that are like real world and useful things that you can make practically, but are trying to serve as like a vehicle to teach you things like web frameworks. So, all the way to week 10, you'll be working on these big week or in some cases 2-week-long projects. And when you finish them, there'll be a nice, cool project that you can put on GitHub, put on your resume, and hopefully we'll learn something from it. And then finally, like the final lap is your final project. You have 2 weeks to do this. Unlike the midterms, you guys get to decide your team, so who you're working with. You get to decide what you want to build. You get to decide your stack or what technology you want to use. So you really get the chance to be creative and make something that you're passionate about. People create amazing things within this 2-week time frame. I'm always impressed by what people are coming up with. And people are very creative. So this is like an exciting time, weeks 11 through 12, to really take what you're interested in and really apply it to the max. You're not going to have lectures during this time, but you might have some advanced topic lectures. Advanced topic lectures just being, as lecturers, maybe we want to talk about like game design, or we want to talk about a new thing in web development that isn't really crucial to your learning, but would be something that maybe some of you would be interested in. So the 4 major solo projects that you're going to get, you have low tide this week. I guess it's not a major solo project, but in week 3 you'll have TinyApp, which is like a Bitly clone. Week 4 you have Tweeter, which is a Twitter clone. Week 7 and 8 you make a pretty nifty interview scheduler, and then week 9 and 10 you're making a project, or you're helping contribute to a project called Jungle, which is like a e-commerce shopping application type of thing. The programming tests. So it says just as important as the projects, no more, no less. Programming tests are happening on Fridays, and there are attempt to have one part of your evaluation throughout this course. We understand that not everyone is amazing at tests, so it's not the be-all, end-all of seeing how you're doing. I think it's a good chance for you guys to reflect at the end of a week and see if there's any concepts that maybe you missed or things you can brush up on and reflect. So they're not something that you should get overly stressed about, but at the same time, there's something that you can prepare for and try to do your best. We'll see a bit more information on this as you get closer to this Friday. You have 4 tech interviews in weeks 2, 3, 8, and 9. And when you eventually are applying for technical positions in the real world, often programming and other technical jobs have a technical part of the interview process. So you'll come in and they might ask you, technical questions off the top of your head. They might get you to code for them a little bit. This process can kind of be new or strange to a lot of people, and it's not necessarily directly reflective of you being a great developer. I could be really great at sitting here coding by myself, but you pluck me out of that situation, put me into a room with like 2 prospective employees staring at me and like quizzing me, and I might perform very poorly. So this is our chance to kind of get some exposure to that environment, get some practice, so that when you eventually have these technical interviews, they're not such a shocking or strange situation. And these will be conducted by people like myself or other mentors who you'll be seeing regularly throughout the boot camp, who will be friends or acquaintances, so it's not such a hopefully not such an intimidating thing. Quizzes, you might have seen a few of these already, but these are just the things throughout your readings as you go through Compass. It'll prompt you, and you can just select your answers and see if you've interpreted the readings correctly. And that makes up the grouping of your assessment, like completion of the activities, code reviews, tech interviews, project evaluations. I think Davey might have talked about project evaluations a bit yesterday, but with each of these major solo projects, at the completion of the project, you will formally submit it, and another senior developer is going to evaluate it, making sure that you've hit all the requirements that the project required, and then respond back to you, giving you feedback, maybe telling you there's some things that you can update, or giving you pros and cons of what you've submitted. And this is actually like a really nice thing. I think initially it can be kind of intimidating, this like project evaluation, but it is very similar to the real world dev cycle. If you are working at a job and you produce some code, you usually submit it for evaluation to either like a QA team or a senior developer who's going to look at it, give you some like feedback. And this is a really nice chance to like improve our code. So it's kind of, I think it can be maybe coming from a traditional school style system, like, oh, you submit something and it gets marked, and that's kind of not the funnest situation. But project evals are more like, I wonder what I did well, what I can improve in. They shouldn't be like a point of contention necessarily. I think that's everything. I know I went through it kind of fast, and again, there's a lot of stuff in there that I don't expect us to all be too familiar with at this point. But that being said, any questions on any of those weeks of material that you guys are going to be jumping into, or anything about this slide and the assessment stuff from you guys here or anyone in Victoria, just let me know. Yep. So the question was, do you get a final grade at the end? No. You're just like evaluated mostly to see that like, you know, you're keeping pace and you're not getting too overwhelmed yourself. And if you do start to get to a point where it's getting intense, it's more that like we want to come in and help and make sure that like you're getting the support you need and things like that. So it's not so much a grading thing, but just more of an assessment to see how we can provide the best support that we can to make sure that, you know, things are going good on your side. You will get like on your project evaluations, you'll get like not grades, but they'll give you like feedback levels for like coding style or how well you met all the requirements and things like that. So you can get a little bit of a quantitative feedback in terms of those things, but not in terms of the whole course itself. Yeah. Any other questions on anything like this? Oh, assistances. So that's, you guys have started interacting with like the mentor queue yesterday and requesting assistances. That's just mentor assistances. So, you know, mentors are keeping track and making sure that everyone's doing okay, and yeah, I guess. Cool. I don't know. You guys are good? Sweet. So I'll send these slides to you in the lecture notes. So if you want to go through and like look up anything like, oh, what was, I'm interested in, I mean, you probably didn't go through this and draw out this thing in particular. Wow, I'm so interested in automated testing for web applications. But maybe you were. You can, you know, maybe do some initial research into a couple of these things. Sweet. So back to kind of the more traditional lecture, and our goal was to look at the dev workflow. And one of the things we want to be addressing or thinking about is incremental coding. So incremental coding, this is the process of like breaking down a big problem into smaller, easier to digest or solve steps. Some of you guys from yesterday were like chefs or like cooking enthusiasts, yeah? So like, what is a dish that is like maybe very challenging to make? Beef Wellington. So like, I'm probably like a very amateur chef, and if I had the task of trying to do a beef Wellington, I would be like pretty overwhelmed and not know where to start. But if someone was teaching me, an approach they might do is to take that like complex thing of beef Wellington and break it down to like the smallest steps. Beef Wellington might not fit for this example, but I know with like a lot of cooking, the complexity comes from like the macro, from like the big picture. There's a lot of things you have to do to get to like a final product, but sometimes with recipes, each individual step might not be that complex. I know, of course, there are things in cooking that like the execution of it is very hard, but if we can break something down into a lot of fine steps, often if I can accomplish one of those steps after another, I can at least come out with a reasonable finished product. I don't know, is that totally off basis? No? So like the super simple example I have here is like if I can slice bread, open peanut butter jam jars and use a butter knife, then I can make like a peanut butter and jam sandwich. Whereas if I just throw the whole task to like a child, like make a peanut butter and jam sandwich and I throw him all these things, it's questionable whether or not he would succeed. And we have to think of our computers as maybe like really smart children to some degree, because they can do amazing things and high levels of computation, but they only ever do what we tell them to do. And if they're doing something, like if it's not working, it's because we've messed up in telling them one part of the step. Breaking down a problem into these smaller steps, it has a bunch of benefits as well. It's easier to isolate errors, and we can refactor or improve code as we go. So if we just create like the first step of slicing bread, and like I'm just butchering that loaf, cutting like meaty 2-inch thick bread slices, from that point onwards, we know I'm gonna make a horrible sandwich. We don't have to like let me finish and make the whole peanut butter and jam sandwich to know that I put too much bread in. So that's going to be our approach to programming. We want to take a problem and see what are the component steps to solve that. So throughout this lecture, our goal, kind of as a group, is to write a node program that takes in an unlimited number of command line arguments. We're going to go through each one of those and print out the sum of those command line arguments, but only if they're a whole number, and we also want to support negative numbers. So this is our problem statement, and probably we want to break this bigger problem down into some smaller steps. But before we jump into that, this will be our first exposure to live coding in like a Lighthouse lab setting. And we don't want live coding to look like this, as it often like can end up in a lot of cases. So with live coding, with me and the other lectures, we don't want you guys to like follow along and code with us. You guys have plenty of chance to be coding throughout the day with your activities. The lectures are more of an opportunity for us to demonstrate larger concepts. You don't need to understand every small detail of what is coded as we go along, but try and understand the like why and the like flow of how a lecturer is doing something. And the huge benefit of lecturing as opposed to reading something or watching a video is that it can be an interactive experience. So you guys, if something's not super clear, you know, ask the lecturer, ask me. If you have suggestions while the person is coding, you know, throw up your hand, be vocal, and then I'll just like improve the experience of the lecture for yourself and others and the lecturer and so on and so forth. It should be like a collective coding experience. I know I do often run into errors when I'm coding, and we can help fix those together. As you watch the live coding, it's an opportunity that you can take notes if you want. If you're an active learner and you kind of want to code along, instead maybe take notes on things that you found interesting, things you might want to research later. Yeah, and especially as the lectures go on, you're not going to understand everything the lecturer codes, and a lecture in this type of thing is not the best way to learn, say, something like syntax. Like if I come up here and say like, oh, to print something to the console, you're going to use console.log. It's going to look this way. That's something that's much easier for you to like understand and learn just looking through a reading or doing a coding activity. So if I'm doing some syntax that's not familiar with you, you can put up your hand and ask what it is, but you can also kind of maybe think about what is it doing. I don't need to know exactly like the syntax for it, but I want to understand more why he's using it or how the program is being run. And then like if you're taking notes afterwards, you can kind of go and do some research on those or ask the lecturer before, after, or during. Like I know some people don't like asking questions out loud, but really if you get more comfortable with it, it is a nice thing to be able to do. So we want to create a program that takes in some number of command line arguments, and we want to sum them all. And so this is the start of our program, or like our project. And before we even jump into coding, we probably want to get our project initialized. And to do so, we're going to need a tool called Git. And you guys have started to use Git, and you've, I believe, had some readings around it. And Git is a big and powerful tool. So don't expect to understand all of it this week or next week. You'll be adding and building the skills around Git as you go throughout the entire bootcamp. But in general, Git is a repository, which is a system for tracking changes in source code during software development. So some things that it helps us with, it remembers the history of our code. It documents changes with commit messages, listing the author of the changes and whatever they wrote as that message. We can use a remote Git repository to back up our data. You guys have started to see that with GitHub. We can undo changes we made. It makes it easy to collaborate with others on code. And this is a big area that Git does for us. It's something that we're not going to see really this week, but as you approach the midterm, that's going to be a big part of Git that might cause some problems, but eventually will also make the project much easier. And it does like so much more than that as well. Today, we're really going to focus on the fundamentals of I, as a singular developer, starting a single project. What should I be doing to make sure I have a nice Git workflow? Normally, I do some like drawings for Git. The whiteboard shows up really poorly on the stream for Victoria, so I'll do my best to kind of like work through some images on Google and stuff to explain some concepts that I might have looked at otherwise. But our basic Git workflow kind of looks like this. We have a couple areas denoted by these like colorful tags up here. The first one I want to draw attention to is the working directory. So the working directory is the one that you guys are most familiar with and you've been using for as long as you have had a computer. The working directory is just the files that we have on our computer. Whether or not our like Git repository is initialized or not, we have our working directory. If I go into Finder and open up like your Lighthouse Labs folder, that's like a visual representation of your working directory. Or if I go over here on VS Code, I can see my working directory over here. The next place we have is I'm going to skip staging area for now, the local repository. So this is the actual Git. This is the, when you do Git init, you're creating this local repository. And what your local repository is like a chain of saved changes starting back when you first created the Git repository. So so this could be like a visual representation of your local repository. We have different nodes representing different points in time or snapshots of our code of our project. And these numbers up here are their commit like numbers or their commit IDs. So maybe I just created my project. I initially do an add and a commit, and I see this first stage on my Git history. And then later on, I update, add some new functionality, and I add another stage along my Git history. So as your project grows and grows, you'll just have a longer and longer chain of saved snapshots of your project. dating all the way back to the inception of your project. We see there's like a branch here. We're not going to look into that just yet. And the mirror to our local repository will be the remote repository. So our local repository is a staged chain of saves on our computer, and the remote one is identical, but on a remote. So another network device in most cases. In our case, we'll be using GitHub mostly. And these two repositories, for the most part, will be kept in sync. So I have the saved changes on my local machine. I do a git push, and it adds, say we didn't have this one on the remote. For Victoria, I'm covering this one with my hand on the screen. If I do a push, it will then update and add this new node to my remote. So we have our working directory, our local repository, and our remote repo. Local repository and remote repo are kind of duplicate versions of each other, or they will be once you keep them in sync. The last area is the staging area, and this is the place between the working directory and the local repository. I like to think of it as like an airlock. So if you're in like a space station or like a contaminated biohazard place, you have like an airlock where when you're entering the ship or like exiting, you have to go into this staging room, the door closes, and like you're in this space for a second, and then when everything looks good, the other door opens and you can go out. It changes pressure, they change air. For Git, our staging area kind of works the same way. We have our working directory. Our staging area is our chance to like add certain files to the staging area, and then we can look at the staging area and see, okay, are these all the things that I want to commit to my local repository? I have like file A here, file B. It shows that like these changes were made to file A, these ones to file B. That looks about how I want it. Then I'll just commit the things. I find a question people often have is like, why is this staging area even needed? And on smaller projects, sometimes it does feel kind of useless because we might be doing the pattern of doing like a git add dot or git add all. So I'm just adding all the files, and then immediately after I'm doing like git commit and then putting my message. So I'm kind of going working directory. I don't even spend any time thinking about this, and I jump right into my like local repository. What I would say as you get to like bigger projects and maybe you're experimenting with different changes in different files, sometimes you get to a point where like you've made 5 or 6 changes on different files in the working directory, but a bunch of them didn't work out, but you want to keep a single change. That's the point where you kind of are like picking specific things. You're like, this worked, I'm going to put this in the staging area, and then I'm going to take that and I'm going to commit it. It just provides an extra stage for you to check and like make sure that you're saving everything the way you want it. And we've talked about it, but if I do a git add, it puts it in the staging area, and when I do a git commit, it takes everything that's in the staging area and commits it. One thing about the staging area is the staging area is kind of like a carbon copy of whatever I added from the working directory at the point when I added it. So if I have like file A, and then I change it, and I like change the first line to be like hello world, and then I add it to the staging area, and I don't do a commit, I just did add, and then I go back to file A, and I delete that first line, and I change it to like bonjour world. And then I add from my staging area to my local repository. It will be the initial state of that file. So it'll say hello world. It doesn't know that I've, since doing a git add, I have updated that file. It would be nice to draw that, but I think we'll go through some examples. It'll be clearer than me talking about it. Any thoughts or questions on this kind of, these different areas of Git or these different commands that we see here? Sweet. Can you remove things from the staging area? Yeah, you can. So if you want to remove things from your staging area, you can do like a git stash. We'll look at some neat ways you can deal with these different areas using VS Code when we start when we start doing our project in a second here. But that's a very good point, because if it's a proper staging area, if I put some things in there that I didn't mean to, I should be able to like kick them out and revise it. So we definitely can do that. One command that helps us with that is called a git a stash, but we'll look at some other ways of doing that in a second. And then the last, coming back from the chain, we see like a git pull. That's if we want to take our remote repository and bring it locally. These last three here are more workflow that you'll see when you're working with other people. Because if we think about it, if I'm the only person working on a remote repository, I will just be pushing stuff to that remote. I'm never going to have to be pulling stuff, because nothing should exist in the remote that I don't know about. Because it's like, it's a lockbox. I'm the only one with the key. I'm the only one who can put stuff in there. So there shouldn't be a time where I open up my lockbox and find like, what the heck, there's like this thing that I didn't put there myself. So for at least these first 2 weeks, this is more of the flow that we'll be seeing. So these are some of the commands. Instead of going through them, let's actually just like start our project that we want to get going. So I'm up in Vagrant, a nice first step that can often be forgotten, especially in the early days. I'm going to go into my lectures folder, and we'll go down to week 1. What is it called? Yeah, week 1. And then what's in here? What am I? Okay. And then we're in day 2. And this is our notes that we've been going through. Let's make a new file. We'll call this a folder. What should we call our new project? We can call it like some command line. And then I'll go into some command line. And we can just right off the bat go git init to initialize a Git repository in this new folder. So one thing, the pattern of repositories to projects should kind of be one-to-one. Each project, which has its like own unique scope, should have a single repository associated with it. We don't want to get into the habit where we have a folder that has a bunch of projects in it, and we're initializing that folder as a repository. We kind of want individual projects to have individual repositories. So just doing a git init, I see I have initialized empty git repository in this place. If I do ls-lah, so ls is to list the files, -lah is to show all files, even like hidden or extension ones, I see that there's a new file here called .git, and that's the file contents of my repository. Next, we're probably going to want to open this. Actually, before that, we probably want to set this associated with a remote. So I can go over to my GitHub. When I want to create a new repository, there's on most pages on GitHub, there's usually like a new button. I can give it a name. So we said some command line. I have a couple options, public, private. In general, we're going to want to make it public. And then down here, there's an extra step, initialize this repository with a README. We don't want to check this because you'll get into a situation where if I initialize my remote with a README, it now has a file that my local repository doesn't. And so if I try to go to push, some of you may have seen this error already. It'll say like, I don't have all the contents that the remote does. So I'll have to do some extra steps of either like removing the README from the remote, or I have to do a pull and then a push. It's easier just to start the repository empty. Create the repository. I know you guys have seen this, so I won't belabor it too much. I have the two options, HTTPS or SSH here. If you have SSH configured, which you should have in the like setup information, you will be able to push and pull from your repository without having to verify that you're the correct person. So that's what SSH is doing. It's like a handshake set of keys to say that, like, yeah, it's me, like, let me get my stuff. If you use HTTPS, which I will use just to show it, you'll be prompted for your like email and your password every time you want to do some stuff. So I'll go git remote add. And I want to name the thing that I'm adding the origin, which is just the conventional name for your main remote. I can have multiple remotes for this project. There could be a situation where I want a remote on GitHub. I also want a remote on like my friend's networked computer. And so I'm pushing to both of them. And I need a way of distinguishing which remote I'm pushing to. And that's with this name here. I could call this anything I wanted. Origin is just the convention for the main one. So hitting enter, it didn't say anything, but if I go git remote, I'll see that I have one remote listed called origin. I don't have any files yet, so we will leave it at that. But now we want to jump into this project, and the first kind of cool hack we'll look at is if you have VS Code, you can open VS Code from the command line using the command code. And then you can either give it a file. So if I just want to open up, say there was a file test.js in here, I could do code test.js, and it'll open that single file. If I want to open up the whole folder, I can do code dot. And I'm going to hit, oh. So I'm in Vagrant, which I don't have this set up for. But if we were to set it up, if I do Command-Shift-P in Vagrant, so Command, Shift, and then P, it opens up like a command interface for Vagrant. And this is where you can find things like settings and so on and so forth. I can also go, here it says shell command install code command in path. So this will install that command line code tool so that I can open stuff with code dot and so on. But for now, we'll just, actually I'll do it in a separate window. So our project was some command line. I'm going to open that up. I've got no files in here. I could go into the command line and use touch to create our new program, but maybe I'll just add the file here, and we'll call it some command line. And so I have one file, and on VS Code on the left here, I see this little icon with a kind of branching structure and this like blue one. So this keeps track of the Git repository that I have. If I see one thing here, it means I have one new change that I haven't committed to my repository. This tool and tab for VS Code is like really handy. You can do all of your like add and commits in command line if you want, and you should get accustomed to that flow. But if you want to experiment with using this one, it's also really nice. So it shows all of the changes from the different files. I only have one that I've made that are not up to date with my repository. Next to the changes, I see a little like plus sign here. So if I hit this plus sign, it stages the change. That's the same as me doing git add some command line.js. Up on the top here, I see a message, and this is the potential commit message that will happen for this stage changes. So I can go initialized some command line program. Once I'm happy with my stage changes and my commit message, I can click this check mark, and that'll commit it to my repository. I can also click on any stage changes and see the change that was made. So in this case, it's not a very visual change because we had nothing, and then I added something, which is just a blank line. I didn't actually like add a blank line. It's just this is a file not existing, and this is a file existing. We'll look at some examples when we have a real change in a bit. But if I click here, my change was committed. I can go back to my command line, and I can do git status, and I can see nothing to commit. So it's taken my change. And then maybe I want to update my remote with this new change. So I can do git push, and I can do origin master, telling it the branch, or sorry, the remote that I want to push to and the branch that I want to push to. What's nice to do on your first push is to add the flag -u, and that says, remember this remote as the main one. So if I push, I'm using HTTPS, so I need to put in my username and my password. We'll see that it wrote to it. In the future now, I can just do git push, and it will know that I mean origin master because I've, on my first push, did the -u flag. And if we look over at the repository on GitHub, we see that I have one new file. I see the file has my comment that I made, and I see that it happened 1 minute ago. All right, so let's get down to the actual programming of our project. So as a refresher, we wanted to write a node program that takes an unlimited number of command line arguments, goes through each and prints the sum of them, only if they're a whole number, whether they're negative or positive. So let's look at this for a second, and let's think of some smaller subproblems that make up this larger problem. So can you push from VS Code to, or only from the command line? To be honest, yeah, you can here with these drop-downs. So, that's another, well, we'll look at another thing, because we had another question about like, oh, if I've staged something, how do I like unstage it? And we can see that possibility with our Git tab here in VS Code, and we'll look at that. But I can also do like a push from or push with this dropdown. Maybe it's just my habit that I picked up, but I often just do the push and pull from the command line. Maybe it's purely because this stuff doesn't come to mind when I just look at this interface. But yeah, you can do it from VS Code as well. Okay, but thinking to this problem, can we think of any subproblems that exist within this overall goal? Yeah. So we want to write a node program. I think I can. We want to write a node program that takes in an unlimited number of command line arguments. It goes through each and prints out the sum of them. If any argument is not a whole number, we want to skip it, but we do want to support negative numbers. So maybe what I'll do is I'll copy this. Okay, so from this, what are some smaller problems? So one would be getting command line arguments. What might be another one? Okay. What would the purpose of this function be? To loop. Okay. Do we have any other thoughts? Check if the number is a whole number. Okay. What else? So, what else? So, adding numbers together. Any other subproblems we see? So logging the sum or sum output to user. Nice. So these are good set of steps. If we were to order them, getting command line arguments probably the first thing that we want to do. After that, we might want to convert the string to numbers. Maybe checking if it's whole. We talked about looping inside of a function. That sounds like a good place where we might want to add the numbers, and then we want to log the sum or sum output to the user. So now that we have these kind of individual subproblems, we can see if we can solve each of them individually on its own, and if they're working correctly according to what we see the program doing, then we can probably try and link them together and see. So we're going to take a 15-minute break. If we can come back at 11:08, that would be awesome. And I always like to encourage, if you have any questions about anything that we've done up to this break, think about them and then bring them up. We'll have like a brief question down before we jump into coding some more of this stuff. Yeah, so I'll see you in 15 minutes. Okay, we're gonna get started up again. I'm just gonna confirm with Victoria that they're with us. Is it good? Nice, thanks, Emily. And Justin. So the first thing we're gonna look at before we jump into it, I realized we had one question that was if I have a change that is staged, so I've done git add, how do I remove that? And I said git stash, but git stash is if I just want to remove a change completely, like I want to go back, I want to get rid of this change I made and I want to go back to my last kind of commit that I had. So if I have a staged change, so this is change, that's the same as if I did a git add some command line. I can use VS Code to unstage it, so I can use this minus to pop it back out. But if I want to use the command line, I can use a git reset command. But someone pointed out here in Vancouver that if I'm curious about what my options are with the current state of my Git repository, I can do git status. And not only will git status tell me like the status of my repository, but it also gives me some handy hints on what I could do. So right here it says use git reset head and then whatever the file name is, these angular brackets are to be substituted with the file name to unstage. So if I did git reset head and then some command line.js, and then now we do git status. I have, instead of a stage change, I have an unstaged change marked in red. So you can do it here in VS Code, or you can do it in the command line and use git status to give you kind of hints on what things that you can do. Yeah. So let's start looking at the first kind of subproblem that we wanted. So the pattern we're going to do here is we're going to say each of these subproblems has their own functionality, so we're going to break them down into functions themselves. So get arguments maybe. You'll find that I'm a horrible speller most of the time, so if you see me making spelling mistakes, please call them out. And this is going to be a function. If we're getting arguments from the command line, do we need any parameters for this? What, like we don't need the right answer. Like, what's our thought? Do we need any parameters or for a function that gets command line arguments? So the comment was process argvs, and that's something we probably are going to be using, but we might not need it as parameters. So exactly, if we want to get the arguments, we'll go arguments, and that's going to equal, what do we say, process argv. And do we need parentheses or do we not need parentheses? Well, if we're not sure, we can always test. So our function right now is getting arguments, and maybe we'll have it just return those arguments. So we can test this. We'll console log the results of calling our function. And maybe we'll open a terminal within VS Code. And we'll just do node some command line. So we have one error. We see process.argv is not a function. So if it's not a function, maybe our next approach is to try it without. And we get this, what looks to be an array, logged to our console. So the first element in our array is this path that says user local bin node. Second element is a another path, users, Travis, all the way down to some command line, so the file we were trying to run. And what we want to do is I want to give this program some arguments after I'm executing it. So maybe some numbers like 12, 5, 8. And so our program seems to be doing that correctly, getting those, but we have this extra junk in here. So testing our first bit of functionality, we see that we're not returning exactly what we want. We need to get this array from the user, but only including these actual ones that they input, not these first two file paths that seem to be in there. And on a little bit closer inspection, they seem to kind of be related to, well, node is the first thing in the command line, and this is a path. It seems to be node. Some command line is the second thing in the command line, and this seems to be a path to some command line. But those are going to be there every time and are kind of useless for our cases. So what could we do to maybe get the command line arguments, only the useful ones after those two path names? Slice. So we could go slice, and then what do I give slice? 1. Okay, we'll try it with 1. So we'll run the program again. And we still have one of the things in there. So we can try 2. And what slice is doing internally is saying you have an argument with some number of things in. Let's create a new array starting at the index that you give it to. So we want to start at the second, which is the third thing in the array, but the second index thing. So 0 would have been node, 1 would have been some command line path, and then 2 would be the start of kind of the ones that we want to get. So 12, 5, and 8. So our first thing is looking pretty good. We get an array of command line arguments from the user. So this might be a chance to say, okay, we have our first piece of functionality. Let's add that change. Let's add a new commit message. Added get arguments function. And we'll commit that. So next, our next subproblem was to convert the strings to numbers. So again, we'll divide this functionality into a function. We'll say, well, maybe we can do these two together. So we want to convert the string into a number and check if the number is a whole number. So we'll try and do both of those. So we want to get a whole number. For this problem, it's probably more likely that we need a parameter because we want to take something and do something to it.
Is there a functional difference between creating a function, like start a function, then name, and then argument, or making a variable or constant? Is there a functional difference between those two?
Yeah, so the question is there a functional difference between maybe this function here? I just want to get those. Where I have declared a variable and set it equal to a function versus if I did this. So there, in terms of what the function does, there will be no difference. Oh, I need. What was my? Anyways, so these will perform the same way. The difference, this one is called a functional expression, and this is a functional declaration. The difference between these two functions has to do with something called hoisting. I don't know if hoisting is something that you've seen in your readings yet, but essentially, if I create a variable here, thing equal 5. The intuitive way of seeing this variable is that if I read from top bottom down this document, I will hit it at line 24. And then at that point onward, it will be usable to me in my program. So if I do console log thing here, I should get the number 5. And if I'm following that same logic, if I try and use thing before it's declared, I should probably get some sort of error. That is what would make sense to me. JavaScript doesn't do it that way. Instead, JavaScript hoists variables within our program, meaning I can use a variable before it's declared, because when my program is running, it does an initial zip through all of the code, finds all of my variables, and kind of like does, well, conceptually it does this. It like brings it, it hoists it to the top of the page, so that this variable, maybe not its value, but exists as a concept before anything else is run. That lets us have less errors, but for everyone else in the coding community, doesn't make sense, because it's not a concept that's common throughout other languages. And so if I do a function declaration versus a functional expression, my functional expression here will get mad at me if I try to use the function before it's declared. So if I do get whole number, I'm just going to get rid of our test up here and get rid of that. So if I run this program, oh yeah. If I get rid of my badly declared function, I will get another error that says get whole number is not defined. So I can't use the function before I've declared it. And when I do a functional expression, it forces me to kind of have good programming habits, where I should use this function only after I've declared it. So now if I go to run this guy, I get here and I don't get a complaining. Yeah. Yeah, so the question was, can you pass a function that has been declared, so this style, into another function? You can. So really, that's the only difference between these two of them, is that a functional expression will enforce you to have proper ordering of calling it. Both of these functions I can pass as arguments to other functions. I can pass their reference around. That's something that you're really going to be dealing with next week. Looking at passing functions around is a lot about the async control flow. That is kind of the concept of next week. But yeah, good question. So this is the style that we're going to be encouraging you to go with, because one, it's a styling convention. If we're consistent in how we write our code, it'll look nice. And two, it doesn't let us do, this pattern, which can be frustrating and makes it difficult to read the code. Especially like if this is a big document and I'm reading it from top down, and I get to this point here where it says get whole numbers, I'm gonna be like, I don't know what that is. Like, how do I find it now? And I'm gonna have to like search through the code. Whereas if my functions are always called after they're declared, if I'm reading top down, as most sane people do, I will always see the function declaration understand at least somewhat what it does before I get to its use case, which is more readable. Yeah. So back to our get whole number. We wanted it to take a num or a thing that we want to check if it's a. Well, first we said we want to convert it to a string or convert it from a string to a number and check if that's a whole number. So we'll get whole number and we'll pass it in maybe an element or an item. So first we want to convert the string to a number. Is number. Any thoughts on how we convert from a string to a number? Parse. Yeah. So one way we can do it is we can use the number keyword, and we can pass it a thing that we want it to try to convert to a number. And once it's a number, then we want to turn it into a whole number, because if we convert it to a number, it could be like 3.5 or a decimal place. What might we do for that? So the question is this a function or is it something else? Anything that we're using with these round parentheses would be a function, like we're executing a function. But it's got this like capital N. What does that mean? So we haven't really looked into this yet, and it's not super important for right now. But in JavaScript, we have this idea that everything is an object, sort of. So we haven't learned what objects are yet, but this capital N for number is referencing that number is an object type or a class of objects. And we're using this class of objects to convert a thing, an item, trying to convert it into a number object. Don't worry too much about that right now, because there are some weird caveats with JavaScript, but that's why we have the capitalization present here. Yeah.
Does parse int recognize decimal numbers and round them, or
Does it? So.
there's like two there's functions that recognize int and recognize float in JavaScript. Do they like if you use the toInt function on the number versus over the float, or it can round it down or up?
If I use toInt on item or on the new number that I have?
On the item.
On the item. So is the question whether it will convert it first to like an integer and then try and round it, or sorry, first to a number and then try and round it to an integer?
Is there not a function online that recognized int or recognized float from string into a particular data type?
And that was. Yeah, look it up, and we can explore it. So the question was around another function that could convert something from a string into an integer, and we can look at that. But we don't necessarily want to convert our thing into an integer, because from our problem description, if it's not an integer, we just don't want to add it. We don't want to convert it into an integer and add it. So instead, we kind of want to go is like whole. And we want to check if this is number is an integer, I guess. So is number is integer. So we have kind of like a two-stage check. First, we're checking is it actually a number, and then we're checking is that number an integer. And only then do we maybe want to return the result of this whole number. So we can do like a conditional where we say if it is a number and it is whole, then we want to return the actually this one. So the reason this is going to work is because of the idea of truthy and falsy. So just from my knowledge of using number, if we try and get a number by using this method from something that isn't number, so like the word dog, we can do an example. So if we go into the node thing and we do a number of like something that's not a number, the result will be none, so not a number. And not a number is a falsy value, whereas if it is a number, so we'll give it 5, we get an integer value, well, a number value, which is a truthy value. So our if conditional will pass if this number is not non. If it's non, it'll fail. Same thing with is whole. Is whole is not the same as is number. It will give us just a Boolean back. So if we go is integer 4.5 dot is into let's do so is integer. So what would, if it seems like is integer is not the function we're looking for, what would we do to find the correct function? Or does anyone know the correct function that we want to do?
You could see if it's equal to like math round of itself.
If it's equal to math round of itself. Yeah, we could do a check like that. I'm curious though, let's do, oops. So we can go with your one, but let's double check JavaScript. So we want to check, we'll just do a search is integer first. And it's that we're using it wrong. So we use is integer on the number, that capital N, like class object, and then we pass it as parameters the thing that we want to check for. We probably could do the math dot with the comparison, but we'll just go with this because we already tried, and instead of failing, maybe we can just correct our code. Or even let's check here, because what we were saying was if I go number.is integer of 4.5, it should return false, and if I do number of 5, it will return true. So our check will be that this is whole and that our first thing kind of didn't return non. Then we want to return the number. So that'll cover the case when our function is given a correct thing. What should we have it return if it's given something that isn't like a proper number? So there might not be a right answer here. Like it depends on what we want this function to convey. We could have it return like not a number. We could have it return like, or we could have it break the execution of our program and give an error message. There's a lot of different things that we could play with. For our case, I'm going to have it just return 0 because I know that later we want to, where did our, oh no, I deleted it. We wanted to loop, and then we wanted to sum the numbers. So if I'm thinking ahead and we're getting the input from the user and checking whether it's a whole number or not, if it's a whole number, we want to add it. If it's not a whole number, we don't want to break the program, we don't necessarily want to do error handling. Maybe we just want to add it anyways and have it not affect the rest of our program. So by returning 0, 0 is like an inconsequential number, we can just loop through each of our inputs and add them together. But let's first check that our function is, we did some command line ones to check the small parts that we were using. But next we might want to check, okay, if I give it a 5, or actually the string 5, what does our program do? So it logs 5. If I give it some gibberish, we get 0. So pretty rudimentary test, but let's assume that it's going to be working beyond that as well. We can go back here, we can stage that commit, and we can add check whole number function, and we can send that off. Okay, so next we wanted to loop and sum the numbers. So we'll create a new function, we'll call it sum numbers. This is probably going to take in an array because we want a group of things and we want to sum it. What should be our first step in here? So we could do a for loop. We could do like classic, they call them like C-style loops, where we decide initial, the step, and the end case, so that x is less than maybe array.length. But there's another way that we can loop through things when we're specifically using an array. And we can do that by saying we want to get each element of our array. And this will loop through our array, assigning this variable element to each thing in our array in turn. So, for example, if we down here just did for let element of no. We would just get each number console logged out from our array. So element will represent first 1, and then it'll represent 2, and then 3, and then 4. We don't have to do like element or array, square brackets, index. It makes it fast to just grab each thing inside of an array. So once we have each thing from our array, we probably want to check if it's a whole number. So we can use our, we'll call it like result, and we can make that equal to get whole number of the element that we're passing. What else do we need to do to have like a tallied sum of numbers? Yeah, so we need to declare a variable that's equal to 0. I know we're going to have to change it, so I'm using let. And we can call this like our sum. And then inside, when we reach each new thing, to sum, we want to plus equals. I could do equals sum plus the new thing, but it's faster to do plus equals the result of getting the whole number. So again, this result will either be 0 or an actual number, and our sum will go up from there. So we're looping through everything, and then finally outside of the for loop, because if we return in here, it's just going to quit after our first number that we hit. We want to return out here. Yeah. So the question is this for of loop the same thing as a for each? And functionally, they are going to operate very similarly. A for each would have to do it on the array, for each. The different thing with for each is that we have to use what's called a callback inside of for each. So this pattern here, where I have a function denoted by this opening parentheses and closing parentheses, and then inside the function I'm using another function, or sorry, I have another function, and then in here I would have access to element. There are some implications of having this style of pattern. One of them being, if I do a return inside here, I'm returning from this function, not from some numbers. Whereas if I do a return inside here, I'm returning from some numbers. They are very similar. I would encourage you to use a for of, unless you need some of the, I guess, flexibility that for each has. You'll see this more next week as you deal with this pattern more so. Good point though, but it's not something that you need to like get too worried about at this point, I would say. Yeah.
Just branching off of that, the for and the for of version, is there a way to like intrinsically access the index without having to
So the question was like, here we have the element really nice, but is there a way to also get the index? And there is. So it's not the nicest looking thing. Ooh. Let's double check, because I think I'm going to get it wrong. So for of get index. So we have to use entries. So what we're doing here is we're taking the array and we're splitting it into a new array that has both the index and the values in it. So, I mean, we can experiment here and we can look at, if we have an array test equal to 1, 2, 3, and then I do test.entries. We'll switch over to browser, because it will give us better console logs. So same thing. We have a test array, just has a few things in it. And then we do test.entries. Does it let us? Ooh. No, this is not stuff we want to care too much. Essentially, it makes a new object that has both the index and the element inside of it, and then using this fancy syntax, we can pull both the element and index from it. So at this point, the level of understanding I think that would be helpful to look at this is to know that this is a pattern you can use. If I do array.entries, it splits up my array to having both indexes and the elements in an object. And I can grab the element and index from that to have use within my loop. In terms of how it does that, that's something we'll see further on. I mean, I just don't want to go too much in depth into it in this lecture because it's not the main point, but if it's something you're interested in, we can talk about it a bit after. The point being, there usually is a way, if you have that question like, oh, I really want the index, This is the way in this case. And if you want to use this, maybe just use it syntactically for a little bit, and then later on we can start looking more into how it's doing that. For now, we'll keep it simple. So let's do a test. Some numbers of, we want to give it an array. We want some of these things to be actual workable numbers, some of them to not be. So our expected value, 5, 3, and 1, we want 9. And we get 0. Why are we getting 0? Any guesses? Oh, well, 1, because we're not even console. This is coming from here. But let's okay, now let's give it another try. So we're getting the correct thing. Say we weren't getting the correct thing and we wanted to do a little more debugging. We could go in here and we could just do like a console log of sum. Use console logs like super liberally. If anything's breaking, just throw them everywhere. You can do console logs with like a little message beforehand, like test 1, and then see like, okay, what's happening at this point? What's happening here? And I'll change this to like test 2. What's happening up here? This might be test 0. Just like flood the gates with console logs and kind of see how the program's executing. The other tool we have is to use the node debugger. So I can add a keyword here, debugger. And then when I run this program, if I run it with node inspect and then some command line, what will happen is I will enter the node debugger. So we see it's starting here. There's debugger listening, and then we're starting on the first, we see the first 3 lines of my program. Write a node program. Oh, it's right. We see the first 3 lines. So by default, the debugger is going to break on the first line of execution. I can say continue, or I can say next. Next will do the next executable thing. So our code continues. The next thing that it's hitting is this function declaration. Or I could use continue, and continue will just run the program until I hit a breakpoint or I hit a debugger. So going continue, we're stopping on debugger. So this is what my code has done. It's defined both of these functions, or all 3 of these functions. We started line 36, started running some numbers. It got to the first loop in our for loop, and it stopped here. At this point, the real interesting thing about using the node debugger is I can type REPL, which stands for read, evaluate, print loop, and I'll get given a similar command line like when I type node, where I can implement my own JavaScript. But this command line is within the context of my program now. So I can do normal things like I can go console log, hey, or I could create my own variable. I can do anything that I would be able to do when I type in node. But what I can also do is I have access to contextually what I would have access to on line 31. So if I do console log of sum, I can see that right now, oh, its value is 1. I can even look higher up and I can say, okay, I know that within this context, I have that array variable. So I can console log array. Oh, I named it foolishly array. So I can see, oh, that's the data structure I'm dealing with here. So if you're deep into some code and you want to see what's happening at that point, but you don't want to do like 8 console logs for like sum, element, this and that, you could throw in debugger, you could run it with node inspect, and then you can kind of dig through the code according to what you want. I could even run functions that I have access to at this level of scope. If I want to do some testing, I could create a variable, and so on and so forth. If I exit out of here, what was it, dot exit? Oh no. Let's go back. So I hit the first debugger. If I wanted to keep executing, I go continue again, and I'll hit debugger a second time because our debugger is in the loop. So we can see how many times it'll hit this. I can go to like the 3rd time it's run, and then I can go in here and I can see how things have changed. I can look at sum, and I can see, oh, it's 4. And then I can exit out and I can go continue. And then I can go back in and I can see what is sum now. Still 4, apparently. Must have had a input that wasn't a whole number. See, and then I can keep continuing. And then eventually we will hit the end of the program. I did all my loops, and we have the debugger disconnecting. So often when I'm programming, I'll start with some console logs if I know it's just like a quick thing I want to check. And then if it's a bigger problem or if it's something more nested, I will use a debugger and kind of poke around at things. But it's a really nice tool to play with and get used to. OK, but back to our thing. It seems like our program's working correctly, or our sum numbers function. So we can add it and commit it. Added sum numbers function. Boom. And so our last step is we need to like connect all of these pieces together. So what we want to do is maybe we want to get the arguments, save it to a variable, super originally called arguments, and then maybe we want to get the sum from running sum numbers on the arguments. Okay, we don't want to name it arguments. We'll call it just args. So the warning I got there was that there's a global variable called arguments, like a predefined node one. So we don't want to be shadowing it or kind of like overriding it. We want to leave that as not used. Similarly up here, I shouldn't have used array. It's kind of a, it's too close to the predefined functions and things we can use around array. It would have been nice to just do ARR. So I'm getting the arguments from the user. I'm passing those arguments to our sum numbers function. And then our sum numbers function should loop through them and eventually return us the sum. At this point, the last step that we had was that we wanted to console log it to the user or give some sort of output. So I could do console log your total is, and then I have a couple. I could do a plus and then add sum. That would be one way to do concatenating strings. The other way is I could do something called a string literal, and I could insert my value this way. So if I use these little backticks, they're the top leftmost character on your keyboard, besides like escape or the F1s. You write text, and then you can insert JavaScript into the text using $, open and close curly brackets, wherever you want. So I've used this here. I could also use it like here. If If you have more complex strings that have like text variable, this pattern can be helpful. Okay. So it seems good. We'll do a test. So 12, 5, and 8. Your total is 25. That seems good. Let's give it some. So 20. It's not counting our non-whole number. We can do, we're still getting 20. So at this point, it seems like we're meeting our functional requirements. And we can do a little bit of like code cleanup maybe. We don't need these. Oops. We don't need these comment lines unless they're providing, information that we can't read from the function ourselves. So by reading this function, it says sub numbers and it takes an array. I kind of have a good idea of what that does. Probably doesn't need a comment. Same with get whole number. If I wanted to, I could leave a single comment above to describe the functionality. In my case, I probably wouldn't for this one. And then finally, we'll get rid of this block. The last thing I would want to do is go through each of these functions and see if there's any like refactoring that we could do, or any way that we could make this like simpler or nicer to read. One thing we could do on this very first function, instead of saving arguments to a variable and then returning that variable, we could decide to do that all in one line. We just want to return what we got back. Down here, we could maybe do a similar thing and just put this check inside of this bracket, but maybe we have, it's easier for us to break it down to steps. That kind of might be a preferential one. I mean, a lot of these are just like, do we want to break these down into 2 steps so it's more readable, or maybe combine it into like a single step if we're okay with that. So that'll make it smaller. You'll find that some people, when they're doing refactoring, their goal is like, how can I take this and just crunch it to as few lines of code as possible? I wouldn't say that's the best refactoring style, because in doing so, sometimes you lose out on readability. So especially in these first couple weeks, I encourage you to like refactor stuff as you go, thinking about if there's redundant things or if you can make it cleaner. But your goal shouldn't always just be to like, okay, let's reduce the number of lines. Let's take that, put this in here, get rid of this whole line, and like continually do things like that. If initially it helps you to have more lines because it's readable and you can get a better logical understanding of what's happening, go with that. As you get like more comfortable with different patterns, you might be able to like pull some things out here and there. The bigger one is like, is it clean? Does it kind of like make sense? Are you doing stuff that could be done in less steps? Things like that. Victoria, could we use reduce instead of the for loop? So reduce, by definition, would be, where are we? Here. So this definitely could be replaced with reduce. Reduce is a function that takes an array and crushes that array back into like a smaller, into less data. Most commonly, it just takes the whole array and crushes it into a single number. So you could do a reduce where you're adding up a whole array, or you're like multiplying each number together. You're taking a group of values and reducing it to a single value. I kind of chose not to do reduce just in this one because I didn't want to be introducing too many new like things and syntax and stuff. But like, great point, you definitely could reduce, and that would be maybe a nice thing to do here. Sometimes you have to think, because if we did this with reduce, we probably wouldn't be saving that many lines of code. Yeah, so that one is kind of a toss-up, whether you would for sure want to use it or not, but it is what Reduce is designed for, and you could use it there for sure. But we'll finish off with our last commit of the project. Integrated different functions to get user input and some whole numbers. Or some characters over, but that's okay. Cool. So just a quick summary. I know we're running out of time a bit. Sorry, there was another Victoria one. Is the number dot item not needed if you were to say number dot is integer item? So the question was here, if we just go number dot is integer of item, is that good enough? I think this will do string conversion, but the problem if we do this way is that this is going to return a true or false value, and we want to return the integer representation of our whole number. So we would still need to convert our item into a number. If we did that, we might be able to like use one less check. Maybe we can actually I invite someone maybe to test that out. If we give number.isInteger and I give it like a string of 5, is it going to give me true or is it going to give me false? That would be an interesting thing because then we could cut this down, but we would still need to get the number itself because again, this would be returning a Boolean. So hit me up on Slack about that. That'd be cool experiment, but also another great kind of refactoring point that we could explore. So just a summary of what we did. We tried to break down our solution into functions. We wrote each block into small steps. A couple of the benefits that had here was we could kind of test and refactor as we went. Another benefit is now our function has some flexibility in that I have a get whole numbers thing, I have a get arguments, I have a sum numbers that I can maybe reuse in future applications or future problems that I'm trying to solve. If we had put all of this code into a single function, then we lose a lot of the reusability that we might get from this pattern. If I want to just sum some whole numbers in the future, I have a function that I can use, and so on and so forth. It also makes it easier to read in that when we're using these like 3 steps, I can see we're getting numbers, we're summing those numbers, and then we're like logging it. It's a little more legible. We kind of linted the code as we went. I maybe should have one time ran our ESLint in the command line that you guys have been doing. With this, I do have lint set up with VS Code. So you noticed a few times, I always forget this one. It'll like just paint everything red. That's just ESLint telling me that I'm not following conventions. We avoided copy and pasting anything. We had to do that one lookup to check up the integer number.isInteger. We could have just went to Stack Overflow and like copied a solution and pasted it into the code. That has a few problems. The smallest maybe being that we don't understand our code. We could be putting something that's not a great solution, and then it has larger implications depending on how much code that we're using with stealing other people's work and so on. But for small things, like that's not such a big thing. We committed often and we committed smartly according to chunks of function that we created within our program. I didn't just commit like, oh, I've done 6 lines of code, time for a commit. I was like, okay, we completed this task. Let's add a commit and a message that like is coherent with the task that we completed. We did a bit of console logs. We also used the debugger in the end. So debugging is a huge skill set that you'll be developing over the bootcamp and one that you'll be coming up with maybe very strongly in the next 2 weeks. Just some problem solving tips. Errors are your friend. I think often people start off and they're thrown those errors when they run their program in here, and they just see the error and they're like, oh, my program's broken. And they just go back to their program and they try and like figure out what's going on, or they get frustrated. Get some experience reading what the error logs are saying. They'll often tell you what line the error is happening, even what character. If you're getting an error at all, it's because you're having like a runtime error, often caused by a syntactical mistake, meaning you expelled or put a character in the wrong position. So those error messages are actually like really nice, because often a syntactical error is like a more simple thing to understand. This is like the traditional, you get stuck, you Google a question, Stack Overflow is often the first one. You look in there and then like kind of try and make sense of it. This can happen a lot. Like you look up the answer and it's like Stack Overflow people are not very forgiving. They're like, what is the most efficient, like cleanest, coolest function I can write so that everyone on Stack Overflow like gives me those upvotes. So the code there is not always the most friendly in terms of like understanding it conceptually or like coming from a more beginner standpoint. So look around, like MDN's a great research point. Look at other Stackflow answers. Actually, reduce is something that comes up a lot for people. Like they get a problem like we're doing here where they have to add up a bunch of numbers, and the first answer that comes up is reduce. And people are like, I barely know how to use a for loop. Now they're telling me to use reduce. I have no idea how that works. If you find yourself in that situation, just like take a step back and say like, there's probably an easier way to do this if I want to do a bit more research. Yeah, think of like what type of an error it is. If you're getting an error message, that's probably like a runtime or a parsing error. Logical errors are the type of thing. We had one when we had a few actually. But a logical error is like your program runs, but it's not giving you the thing that you want it to do. So you've made a mistake in how you're telling the code to execute. They can be a bit harder to understand, and to fix them, you can do things like a dry run of the code in your head, use the debugger. That can be very helpful with logical errors, and just like poke around. And yeah, parsing errors, we kind of looked over this a bit. And if you've done a little bit of this problem solving, and I encourage you to do this because it's a big part of being a developer, is being good at Googling things. It's being good at like just trying to problem solve. So it's good to practice that. But if you're working at it too long, like call up a mentor and get some mentor support. Like as a reminder, if you're working at something for 15 minutes with no headway, flag a mentor. Flagging a mentor is also a skill set that you'll get better at as you go on. It's not helpful to just say like, oh, it's broken, I don't know what. Think about like what led up to the problem that you're having. What have you tried so far? If the mentor is helping you, be a part of their problem solving process, see what they're Googling, see what they're doing to try and work through it. And also, definitely use the mentors for more than just being stuck on something. If you want them to go through your code in a code review to suggest any possible improvements, even if your code is working perfectly fine, do that. The other thing that I think is very helpful to ask mentors on is just like conceptual understandings of different topics. Maybe nothing's broken, but you're using a new thing. You're like, I don't really understand why this is working, or I don't really understand what the purpose of this thing is. Flag a mentor over. They'll do their best to explain it and stuff like that. We use no debugger, but there's another tool called JS Tutor. Some people find this very helpful. You may find it helpful, you may not, depending on on that, you'll use it more or less. So let's take some of our code. I'm going to copy this. We'll go over to the JS Tutor. It's got this big box where I can paste code in it. I don't have the option here to get command line arguments because it's running in the browser. So I'm just going to give it like some hard-coded data. But other than that, it's the same function or same functionality as our other program, where summing the numbers of this array I gave here, which will check if they're whole, and so on and so forth. I can then click this button that says Visualize Execution. It'll take a couple seconds to load up the program. And I can hit this button forward, and it will run step by step, kind of like our debugger did, through our program, but with the added benefit that it'll visualize what the code is doing. This can be a little intimidating at the start. It's like, whoa, what is the global frame and objects? But as we tick through this, I'm sure you'll be able to pop out some patterns. So we see that we have two variables, get whole numbers, sum numbers, and they're both pointing to two functions. And within our code, we've just declared two functions. If I go forward again, it looks like I am, see a green arrow for the last thing that was run. I started running the sum numbers function. The red arrow is the step that will happen next, and I'm inside the sum numbers function. And if I go next, sum is now set to 0. An array is pointing to that static data that I passed in. And we can just tab through this execution and see, one, our red arrow kind of jump up and down based on where it's supposed to be going. And we can see our data being updated here on the right. Our sum incrementing, and then eventually we're checking in the isWhole function if that number that we passed is in fact a whole number. So we'll go through that execution. It's returning 1, and we're adding that to the sum. So the sum's at 1 now. We're going back up and checking if it's whole. Returns 4. We add it to the sum. We see the sum now uptick to 5. And the red arrow jumps around again, getting our last number, which it is. We see it's not whole because it's got false. And its return value is 0. And then our sum remains unchanged. And then lastly, we're returning our sum, which is 5. And we're console logging it in that very last thing. So it's nice to just see the order that the code gets run and what the variables' values are throughout the execution of your code. I think it's really nice, especially early on, to throw some code in here and see what's happening. It's like a web application, so it's not the easiest thing to always use because you have to open this up, copy your code, paste it in here. But it'll really help you get a grip, especially on loops and conditionals and things. Maybe in the first 2 weeks or so. Cool, that's everything that we were going to go over. Did anyone have any questions on, well, anything, but particularly kind of the debugging stuff we looked at the end there? Cool. I'll be around for the rest of the day. I'm also always available on Slack if any questions come up about this material or other stuff. For your morning lectures, you'll have the lecture, and then the lecturer will always send out lecture notes. And that'll be usually any conceptual stuff you went over, but also usually the code that you might have written together as a group. So I'll be sending that to you pretty shortly here. And yeah, you can make it a habit of, if there was something you saw in lecture or some code that was interesting, you should be getting it pretty regularly from the lectures as well. I'm just going to check in with Victoria. Cool. Thanks, you guys. You've been great. Thank you, Victoria, for vocalizing your questions in Slack. I know it can be hard being remoting into a lecture, but you guys did great. And yeah, have a good rest of the day.